The last topic is about enthalpies of formation. So basically, in this topic, you will learn where this value, if you look at this reaction we did here, where these values come from, or the enthalpies of the reaction. And they come from doing a calculation where you have what we call the enthalpies of formation of the constituent compounds, reactants and products, and you compare them. There are a few things to remember. Is that we have standard conditions, and those are 25 degrees Celsius or 298 Kelvin and 1 atm for pressure. So the delta T, when you see this kind of like an O at the end, that means standard. That's the standard. These are the standard states, the conditions. The F is, of course, added for the enthalpy of formation, and this one involves 1 mole of the compounds. 1 mole. So in this case, you have to incorporate your coefficients. So pay attention to coefficients. Coefficients. These values are found in your textbook. They're Appendix C, but on a test or a quiz, they will be given to you. All you have to do is just use them in calculations. So I'm going to show you that appendix. It's called Appendix C, right here. The one you're concerned with, the column you're concerned with is the first column, and they are listed by elements, where those elements make up different compounds, especially the most relevant ones, like here's aluminum, barium, etc. And again, we're only concerned with this column right here. But these other columns you will study in Gen Chem 2. So we will be using this today to look up some numbers from here. And you will be using them, of course, when you do problems from the homework. So let's get back. There are a few rules to remember. Is that the heat of formation for elements, so remember your diatomics or whatever, these are 0. There's no heat of formation. So if you're given something like Cl2 as part of an equation, well, that's an element. So it's going to have an HF of 0. In case it's not given and you're wondering where it is, it's an element. So that's going to be 0. The coefficients of the products and reactants in the thermochemical equation must be taken into account. As I said, the coefficients are used in calculation of the heat of the reaction, enthalpy of the reaction. And here's the equation. The heat of the reaction is the sum of the heat of formation of the products minus the sum of the heat of formation of the reactants. Remember, it's products minus reactants. Here it is. That's the equation. And we have an example to use. So when you get a problem like this, you may be asked to calculate for delta H of the reaction, or it might give you the delta H of the reaction and everything else, but you may need to calculate for one of those of the heat of formation for one of those compounds, whether it's the reactant or the products. So be able to do both. But let's just do this problem, and then when we meet next time, we can talk about different types of problems. Hydrazine, N2H4, is a fuel used by some spacecrafts, and then it is normally oxidized by N2O4 according to the equation right here. So these are our reactants and these are our products. We pay attention to the coefficients. calculate delta H of the reaction for this reaction using standard enthalpies of formation. So the first thing we need to do is go look up these numbers. So we're going to write them here on the side. N2H4 delta HF let's just N2O4. So these are our reactants and these are our products. Okay, very critical that you pay attention to the phase. This is liquid. This is gas, gas, and gas. If you end up mixing them, let's say you mix them up with let's say a different phase, you will get different values. So be very careful. So let's go look them up. N2H4, N2O4, and N2O. So these might be found either in the nitrogen or the oxygen. So let's go. Okay. So let's look for N2H4. N2H4. We'll look under nitrogen. Here we go. So I'm going to make this bigger so you can see them. Here's the one for liquid. 50.63. N2H4 for liquid is 50.63. Look at how the gas is different. 95.35. So you choose the last one right here. 50.63. So let's write that down. Kilojoules per mole. Let's go now find N2O4. And it's gas that we're looking for. That's 9.079. N2O, it's right there actually, gas, right above it. So it's 82.05, 82.05. And of course, water it's in the gas phase. We go and look for it. So here it is, negative 241.8. Very well. So we have our values. Now we set up our equation. Delta H of the reaction is products minus reactants. Products minus reactants. So the sum of the products minus the sum of the reactants. So it goes like this. Watch. Doesn't matter what you start with, whether it's N2O or H2O. We'll start with N2O. 2, I have 2 moles times the delta HF of N2O plus 2 times delta HF of H2O, close parentheses, minus, because that's the sum of the products, minus, there's only a 1 mole here, so that's just the delta HF of N2H4 plus delta HF of N2O4. And I just go ahead and plug in. So that's 2 times for N2O is 82.05 plus 2 times negative 241.8 kilojoules per mole minus 50.63 plus 9.079 kilojoules per mole. So notice the setup here. And if you're writing it as we're speaking, make sure, again, it's written correctly. It's products minus reactants, not reactants minus products. So be aware of that. So you plug that into your calculator. And if we plug that into the calculator, we do this side first and then minus that side. This would give us negative 467.20, but of course that's going to be negative 467 kilojoules per mole. That would be our delta H of the reaction.